Have you ever really thought about what's going on under the hood when you have like a dozen browser tabs open, you're streaming music, and you're trying to get some work done all at once? Well, today we're going to pull back that curtain. We're going to follow the secret life of a single computer process from the moment it's born to the moment it's gone.
It really all boils down to this single question. That feeling of just seamlessly jumping between tasks? It's not magic. It's actually a super organized, incredibly fast-paced drama playing out inside your computer. And by the end of this, you're going to understand exactly how the trick is done.
So here's our game plan for today. We're going to follow the story of a process from the very beginning. We'll look at its ideal journey, what happens when things get messy, meet the secret managers running the whole show, and then, most importantly, we'll talk about why any of this actually matters to you. All right, every story has a beginning, and ours starts here. Every single program you run, your browser, a game, even a little background update you don't even see, it all starts its life as just a simple, inactive file sitting on your drive.
So what in the world is a process? Well, the simplest way to think about it is a program that's been brought to life. The moment you double-click that icon, you're telling the operating system, hey, take that program file, that blueprint, and turn it into an active running thing. And right at that moment, in technical terms, that process enters what's called the new state.
Okay, so now for its first big move. The operating system picks our new process and moves it from your slow hard drive into the super fast main memory, the RAM. And once it's there, it gets in line in something called the ready queue. Just picture a line of tasks, all prepped and basically tapping their feet, waiting for their chance in the spotlight. Now, let's imagine a perfect world for a second. In a perfect world, a process would have a very, very simple life. Let's take a look at this ideal journey, what engineers like to call the happy path, where absolutely everything goes according to plan. So it goes like this. The journey starts at new, right when it's created. Then it moves to the ready state, just waiting patiently in RAM. From there, the system gives it the green light, and boom, it's in the running state. It's finally getting the CPU's undivided attention. And once its job is totally done, it's terminated. Lifecycle complete. Seems pretty simple, right?
Now that running state, that's the whole point. This is where the CPU is actually crunching the numbers and executing the program's instructions. But here is the absolute key to understanding multitasking. On a single CPU core, only one process can actually be in the running state at any given microsecond. Just one.
And finally, we get to the end of the line. When a process finishes what it needs to do, it gets terminated. But it doesn't just vanish. It has one last super important job to do, called deallocation. It has to give back all the resources it borrowed, especially its little slice of RAM, so that all the other processes waiting in line can use them. It's kind of like the ultimate act of digital recycling. But you know how it is. Life is rarely that simple and straightforward. A process's journey is almost never a straight line. So now let's get into the drama, the delays, the interruptions, and the conflicts that are happening inside your computer all the time. To really get the drama, you have to know about the two main management styles. First, there's non-preemptive. Think of this like a really polite guest at a party. Once they have your attention, they keep it until they're completely done talking. Then there's the much more common style, preemptive. This is like a VIP suddenly walking into the room. The process that's currently running can just be interrupted, booted out, and sent back to the ready line because something more important just showed up. Or maybe just because its time was up. But hey, sometimes the process itself is the one causing the delay. It might get to the front of the line and say, whoa, hold on, I need to go grab some data from the hard drive. Now, you have to remember, the CPU thinks in nanoseconds. The hard drive is an eternity slower. The system can't just grind to a halt and wait. It's just like being at the grocery store, right? If the person in front has a problem with their coupon, you don't want the cashier to just stop working. You want them to move on to the next person. And the solution for that is to send that process to a special waiting room, the wait state, or sometimes called the block state. While it's off doing its slow task like reading that file, the CPU immediately grabs the next process from the ready queue. This is how your computer stays fast and responsive. And here's the kicker. Once it's done, it doesn't just jump back in front. Nope, it goes right back to the end of the ready queue to wait for its turn all over again. So, who's making all of these lightning-fast decisions? Who decides which process gets into the party in the first place, which one gets to run next, and who gets the boot when things get complicated? Well, it's time to meet the powerful, invisible managers of your operating system, the schedulers. There are three main players here. First up, you've got the long-term scheduler. Think of this one as the doorman at an exclusive club. It decides which new processes are even allowed inside the RAM. Then you have the short-term scheduler, also called the dispatcher. This guy is making split-second calls, picking the very next process from the ready line to send to the CPU. And finally, you've got the medium-term scheduler. This one's the bouncer. If the club gets too crowded, it's the one that decides who gets temporarily kicked out to make some room. So what happens in a real worst-case scenario? Imagine one process after another needs to do something slow. They all get sent to that wait state, and all of a sudden, the waiting room is overflowing. Your entire RAM is just clogged with processes that are all just sitting there, waiting. Nothing is getting done. And this is when our bouncer, the medium-term scheduler, steps in. It performs an action called swapping out. It literally grabs some of those waiting processes and moves them out of the super valuable RAM and back onto the slower hard drive. This frees up space, so more important tasks can actually get in and get work done. This is what creates the suspense states, processes that are just in limbo, waiting to get swapped back in when there's finally room for them. Okay, I know this has all been pretty deep in the technical weeds, but here's the really cool part. You can actually see this whole drama playing out on your own computer. So let's bring it all back home, right to your screen. If you've ever popped open the Task Manager in Windows or the Activity Monitor on a Mac or run the PS command in Linux, you've seen a list of these processes. Every single line on that list is one of the characters in the story we just told. They're all living through these states, being born, waiting in line, running for a split second, maybe even getting stuck in a waiting room. It's a real-time window into the secret life of your system. So the next time you see that little spinning wheel and your computer feels like it's slowing to a crawl, you'll know what's really going on. It's not just being slow, it's a complex drama. Is there a massive traffic jam in the ready queue? Did some high-priority VIP process just cut in front of everyone else? Or are way too many tasks stuck in the waiting room? Now, you actually know the questions to ask.